build on what we did in the last video, which was looking at how to find the nth term or the general formula of a sequence. And today I'm going to show you how you can extend those skills to quadratic sequences. And we're going to jump straight into 3 examples and we'll see how that goes. So let's just recap what we did before. You take a sequence that looks something like this and you're trying to find that formula. If you remember, we looked first of all at the difference, so we look at what's going on between each of the terms, and we can see here we're subtracting 2. We also said let's look at what comes before, so in this one, this here would be our n equals 0, and we can see we've got 2 key elements which we can put together to say, well, I've got -2 every time n changes, and we're adding on 5 to start off with, starting from 5, subtracting 2, and if you remember, n tells us the position of each term. So this sequence here, we could say, would be -2n plus 5, because it goes up by 2 from 5. Sometimes we're going to see sequences that don't always fit that pattern. Let's look at this sequence here. We've got 8, 11, 16, 23, and 32. When we move up this sequence, the first one goes up by 3, but the next one goes up by 5. Then we go up by 7, and then we go up by 9. So unlike the previous one where we had a common difference, everything was the same, unfortunately we can see here that that's not the case. But when we look at those differences, 3, 5, 7, and 9, we can see that the amount that's changing each time is the same. We can say, actually, the difference of the differences is 2. We call this a second difference. Sometimes people label it like D with a little 2 down the bottom to say it's 2 for second, not squared at the top. So we can look at this and say, okay, we've got this second difference. It's the second layer of difference. And what this tells us about the sequence is that it's not going to be linear, i.e. going up by the same amount each time, but it's changing on the second level. So it tells us that this sequence is going to be a quadratic. Oh, no, that's your pencil. So when we're doing this, we can use something called subtraction method, which helps us to take the quadratic sequence we've got and bring it back to being a linear sequence that looks something like this. The idea of quadratic and subtraction. We know we've got this second difference, this quadratic sequence. So let's think about n squared. We know the first term is 1, the second term is 2, and so on. So n squared, 1 squared, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. So let's take all of those terms and let's just eliminate or subtract them from all of the ones we started with in blue. What we can hopefully notice is when we do 8 minus 1 we get 7, 11 minus 4 is 7, and for all of these we get 7. So that tells us that we must have 2 parts that make up this sequence. We have this n squared sequence here, and then whenever we get rid of that, we only have 7 left. So by combining those 2 things, the n squared, because we knew it had a second difference, and we add on 7, we're going to get the sequence in blue. We call this UN referring to the sequence we're given the question, the sequence we're starting with, the sequence we're looking to find the value for. So the answer to this sequence is n squared plus 7. If we were to put the numbers in, so like let's say we chose this one here, 3 squared is 9, so 3 squared plus 7 is 16, and we can see the term is 16. So let's try that again on another sequence, same idea. We look at the sequence, we first of all look for our differences. We can see as we go through each one, We've got 4, 6, 8, 10, and 12, so they're all different. When we look at that second level, we can see that they're all 2 apart, which tells us our common difference is 2. Common second difference. Let's try that again. Common second, sometimes called the second diff, is 2. There's this one here. So we take the sequence, we subtract n squared, which is 1. Always the same numbers for n squared, if it's just 1n squared, because square numbers are always the same. So we subtract them to see what we're left with. Let's see what we've got. We've got 0, 1, 2, 3, 4, and 5. Now this time, unlike when we had 7 every time, we've got a different number. We've got 0, 1, then 2, then 3, then 4, and 5. But what we can do is think about that set of numbers there as a sequence on its own. If it was a sequence like the ones you've done in the first 2 practice activities and the ones we did in the first lesson, we look for that difference where we can see, on ruler tool, it's going up by 1 every time. We also could look back to that n equals 0 term, would be -1. So this green sequence here would be n minus 1. We've also got this n squared. If we put those two together, we have the n squared, and then we put on, and I'm going to put it in brackets, you don't need to, but just to show you that it's like a whole bit, the n squared and the n minus 1. So this sequence here, the un, is n squared plus n minus 1. Anytime you get a sequence, you look for your first difference. You can see it's 8, 14, 20, and 26. No common first difference. You can see, however, if we go underneath, we've got 6, 6, and 6. Remember last time it was 2, this time it's 6. This tells us the second difference is, but remember we want a coefficient of n squared, so we do 6 divided by 2 is 3, second difference divided by 2. So let's take our sequence, because we know that when it's 2, that's 1n squared, so if we've got 2, 2, and 2, that makes 6. Oh, she's not coming to school today. So this time we're going to subtract 3n squared. So remember n is 1, n is 2, n is 3, n is 4, n is 5. So 3 times n squared would be 3, and we've got 4, so 12, 9, 3 times 9 is 27, 4 times 4 is 16, times 3 is 48, and 5 times 5 is 25, times 3 is 75. We subtract all of those to see what numbers we're left with. We get -3, -4, -5, -6, and -7. We can see the difference is -1. n equals 0 would be -2. So that part of the sequence would be -n, -2. We've also got that 3n squared, and there is our formula. Now I'm not going to show you how to do this one in the video, but I just want to show you very quickly how you can identify, and then you can use the same method to solve. Let's say you saw a sequence like this. Okay, hopefully you can look at that and see that we have a little number pattern here. We can see the black ones, there's 4 every time. So the black tiles are always 4. The grey go 1, 4, 9. So hopefully we can see they have a common difference of 3 and 5, second difference of 2. So you know it's going to be something n squared, but you can figure out what that one's going to be yourself in the questions today. So, to summarise, how do you find the nth term of quadratic sequence? Look at the differences, find this second difference, which here we can see is 4 every time. You subtract, you divide that by 2, and then you subtract that many n squareds. Here it gets 2, so we subtract 2n squareds. Look at the sequence you're left with, try and make that. Think of that as a sequence on its own. So here we had 0, 1, 2, 3, and 4, which is n minus 1. And then you just put them together. So we took the n to n squared, the n minus 1, and put them together to make a sequence. So you can have a go at this, see how